Okay, so at the top, if I'm swinging something in a vertical circle, like a bucket of water, or something unexciting, like a ball that's attached to a string, then at the top, the centripetal force, the sum of the forces, will be Fg plus Ft, and that'll be equal to mv squared over r. So the amount of tension that I need in the rope is smaller than it would be in other spots because gravity's helping me. The Ft I would need here would be equal to mv squared over r minus Fg. Okay, so that's at the top. At the bottom, Fg is acting down, tension is acting towards the middle. And so the centripetal force at the bottom, the sum of all the forces, would be Ft is going towards the middle, so it's positive. Fg is going away from the middle, so it's negative, is equal to mv squared over r. If I rearrange for Ft, I don't like having more than one equal sign in a line. If I rearrange for Ft, take your Fg over, it'll be equal to mv squared over r plus mg. At the bottom, the tension in the rope is going to need to be bigger because it has to not only supply enough force to keep the object in the circle, but it also has to balance out gravity. If the rope is to break, it's going to break at the bottom where the tension will be the biggest. Right at the top, and imagine swinging a bucket over your head. And if you have a bucket at home, if your mother or father or someone has a scrub bucket, take it and don't fill it all the way at the top with water because it'll be too heavy. But put like a third of it with water in it, and then take it outside because then if you spill it, it's only going to help the grass. And try swinging it around in a vertical circle or around your head or like around your body, so a vertical circle, and you will find that you don't need to put nearly as much force on at the top. And then if after you swing it a couple of times, then see how slow you can swing it. And you will get to that spot where you can feel the water just about to come out. Because if you swing it too, like the more you slow it down and slow it down, I'm on a slight sidetrack here, but if we go back to Fg plus Ft is equal to mv squared over r, like the Fg is what it weighs. It isn't changing. And so the more you slow and the m isn't changing and the r isn't changing. So the more you make v tinier, this side also has to get tinier so that the two things will stay equal and everything will stay in the circle. So if you slow the bucket down, slow the bucket down, slow the bucket down, this side gets smaller and smaller and smaller. And so the only thing on the other side that can get smaller is the Ft. So you don't need as much tension. When you're going slower and slower, Ft gets smaller and smaller and smaller, and you will get to a speed where the Ft will be 0. If you go minusculely tinier than that speed, now this side will be bigger, right? The V is smaller, the Fg will be bigger, and the water will fall out of the bucket. And the bucket actually will even fall out of the circle. So if you try it outside, you can feel that spot. If you go slow, keep going slower and slower and slower, you can feel the spot where you know it's about to come out of the circle. And if you're smart, then you'll speed up right away. If you're not, then you'll be wet. Okay, and then so this was the top, the bottom. On the side, it's acting just like a horizontal circle. So Ft is acting in, and the Fg is acting downward, which is perpendicular to the direction, like to the center. So it isn't going to change it at all. So the Fc will just be the Ft will be equal to mv squared over r. Okay? Other ones that are going to come up, perhaps, there's a cool one somewhere in your textbook where it's a motorbike. And the motorbike buddy is going around the circle, like he's doing a loop-de-loo on this track. So at some point he's going to be upside down here. It's hard to draw a motorbike upside down. And so what's supplying the centripetal force? The normal of the road pushing down has to be equal to mv squared over r. And if this is flat, then it's going to be like mg is equal to mv squared over r. So there's going to be a minimum speed that he can go. So hopefully you're getting the idea. So what are we going to do? We're going to do Fc is equal to mv squared over r, and then find out what our Fc is. And remember, Fc is the same as F net, or the same as the sum of the forces is equal to mv squared over r in that particular direction. Okay? So next day we'll look more specifically at curves that are tilted. They're called bank curves. But your homework over the weekend, or your suggested problems for the weekend, are going to be some practice ones on a sheet. Okay? I think like 1 to 7 maybe. All right.